This problem requires the understanding of the Hooke's law. So you have, when you apply a force onto a spring, it stretches by a certain amount. The next you apply another object and it stretches by another amount. What is asking, what is the amount of the force? Let me explain this one. So you have the spring here. This is equilibrium position without applying anything. And then you hang out a mass onto this one. You have a mass here. And this is unstressed. Not stressed. Or without applying any force. All the distance are measured from this position. So when you apply an object, this weight is 135 Newton, this weight. Then it stretches by 21 centimeter. This is 21 centimeter. And it says what should be the weight of the fish so that it stretches by 31 centimeter. This one should be 31 centimeter. So you just need to find it out, the weight of the fish. So we're going to use the Hooke's law. What is the Hooke's law here? The Hooke's law is force S times K times X. And this is the applied force. This is the applied force. This is the spring constant, and this is the displacement, applied force. If I use the restoring force, then you have to put the negative sign here. But if you're using the applied force, then you don't have to put the negative sign here. So let's start with this one, F1. We call this as an F1 force, and we call this as an F2. F1 is equal to K times X1. Remember, the spring constant does not change with the weight. It is a constant for a spring. So F2 is equal to K times X2. So I'm dividing F2 over F1. So F2 over F1 is equal to X2 over X1. Okay, let me write down on this side now. So from that equation, F2 would be simply equal to X2 over X1 times F1. X2 is 31, X2 is 21, and the first force is 135 Newton. If you do your math, the answer you will get is 199.3 Newton. So that's the weight of the fish. Okay. And it makes perfectly sense, because when you have the fish, it stretches more. So that means it has to have more force.